I'm Robin. I'm one of the founders of the program. I think I've tried to spend some time with all of you, but I apologize to those who haven't gotten to. I'll do that today and the rest of the week. In the meantime, we have a very excellent guest speaker. Her name is Robin Schwartz. She is quote-unquote the math lady, and started her career as an electrical engineer. Has now branched out to do a bunch of interesting and different things with her career. So, one thing we want you to learn from this program is you may one day do engineering in college, and even after college, but that's not the end of your career. That's not all that you will do. And so where can careers go? What can you do with it? Why is STEM important? And Robin's going to talk to you guys about that stuff today. So it's pretty informal as always. If you have questions in the middle, just feel free to raise your hand and make it a lively discussion about things that you're curious to learn more about. Okay? Thank you.
Okay, thanks. I have probably way too many slides, so I'm just going to do a few of them. It's always hard to know exactly how much time someone's going to allot. I may need help here with technology, so I'll have to do that. How many of you are rising seniors? How many of you are taking math senior year? Good. How many of you are rising juniors? Okay, excellent. We got rising sophomores here. And what about rising freshmen? I got any? Okay. So it's kind of a pretty good mix in here. Like Robin said, I'm Robin, the math lady. There's a lot of Robins. My last name is Schwartz. I just have to figure out how do you make this thing go here? Let's see.
Can you give a slideshow?
Yeah, slideshow, right? Where's that at?
It's on the top.
Ah, see, I'm back in the old days. Slideshow from beginning. So I usually started as an electrical engineer. I'm just going to speak a little bit about how I kind of navigated my way through different careers and why I did that. But engineering is a fabulous background. It's a really good, strong foundation, and I'm going to share with you today kind of my path and how that might help you formulate some ideas. And I'll also talk about math and education. So my background is electrical engineering. Some of you are working with soldering irons and wires and things like that, and that's one of my previous lives. When I went to school in the 1980s, a long time ago, as a female engineering student, people would ask, so what's your major? It was a conversation in college. And they'd look at me and my closest friend and they'd say, you're engineers? Like, what's been the response when you tell people what you're doing with your summer? What do people say to you? Anyone share? What do people say? Yeah?
I think most people find it pretty interesting. They don't really have so much exposure to that.
Yeah, something very different. What else? What else do people, what other kinds of responses have you had about going to an engineering program during the summer? Anyone else? Anyone want to share? It's okay if you're shy. I teach in the classroom, so it's okay if you're shy. I would find people were like, well, why would you want to do engineering? Why would you want to study? Kind of got that response. I don't know if you guys have gotten that response, but why would you want to study? So people were surprised. They had a certain specific idea of what an engineer should look like. And in my case, they were probably expecting some guy, and actually Rob and I were just talking, and he gets feedback sometimes that they expect a female. What would happen with my resume is they would expect a guy to walk in, or I would get Dear Mr. Schwartz. So I called myself Robin the Math Lady, not only to identify gender, but really more importantly, I started my business 13 years ago, and I would leave voicemails. It was pre-cell phones, pre-texting, and people would not call me back. And I'd start getting a chip. Why come they're not calling me back? They thought it was Robin, their sister, or their neighbor, or some other Robin. Robin Schwartz, too generic. Robin the Math Lady, they got it right away. My first company was out on Long Island. I worked very similarly to how I observed many of you working at a bench with a whole bunch of equipment. In those days, there was no laptop sitting next to us, but a lot of soldering, a lot of test equipment, things like that. And so my first company had 900 people. I was the first female engineer they had ever hired. And this was 1985. This wasn't, a long time ago. 2 years later, they hired another female engineer. We're best friends instantly. But it was so unusual at that time to be a female electrical engineer. And so I just urge all of you, whether you're male or female. I had the same thing happen when my son needed a dentist. The regular dentist wasn't in. So they said, oh, Dr. So-and-so, we'll see you. And I said, oh, when does he have an appointment? It turned out it was a lady dentist. Okay, because my uncle was my dentist. So we all have these preconceived ideas about who should be doing technical work. How many of you, right, you're all on a computer? Does this look linear? What do you guys think? How many of you have taken some kind of regression, things like that, maybe statistics, integrated algebra, trig, things like that? Does that look linear? What do you guys think?
Kind of. It looks pretty linear, except for a few points.
Okay, anyone else? Yes?
There's a positive correlation, but, yeah, positive correlation.
Positive correlation, yes.
It's mostly linear, but some places it curves
Kind
a little
of
bit.
bends a little bit. Anyone else? Anyone? What about the scale?
Oh, never mind.
What are they showing here?
Oh.
What are they showing? Yes.
Transistors and processors.
Yeah, good. Anyone add to that? Why'd they do this kind of weird scale here? Kind of, yeah.
I think it's logarithmic,
Excellent. Good. How do you know?
because it's in powers of 10.
It's in powers of 10. Now, why do they need a logarithmic scale for this graph? And this makes all this possible, right? It makes all this possible. Why did they need it? Yes.
So that you can like fit all your data on.
Yes, you can fit all your data because in 1988, I had a laptop that was 16 pounds. It did almost nothing. And my manager, look how big I am, my manager would be upset if I didn't bring it on an airplane on the way to a conference or something. Like, I can't carry it. So that was back in around this like 280, oh, it wasn't 286, but this is when they first introduced it. So there were only 100,000 transistors on a chip. And more recently, I tried to find a more recent graph, but I couldn't find one. There's now a billion. So how do you get a billion and 100,000 on the same graph? You need to use a log scale. Right? This is 10 to the what power? This one? 6. Excellent. And this one? 9. Those are always the ones I want everyone to know, is the math lady. So that's really what it looks like. It really isn't linear. It just looks linear. Now, how many of you saw this last summer in the New York Times? What are the hands doing? What do you think the people are doing here?
Answering your question.
What does it look like they're doing? The hands or the people? What are they trying to portray?
Raising their hand.
See, that was my interpretation. What do you think that they were trying to make it as?
They're drowning.
They were drowning. But I saw it as they're raising their hand. So there's actually a huge amount of PR that our field needs. All the STEM fields really need. Science, technology, engineering, and mathematics. Because it has this sort of nerdy kind of quality, and people complain about when am I going to, they'll say, when am I going to use this? And so I'll talk about that in a few more minutes. But engineering is foundational. My father's a physicist, and so my dad would ask my brother and I questions like, how many cars go over this bridge every day? And how much money do the tolls collect? My brother's now a meteorologist, internet guy. My mother's an actress. So when we had these conversations, my mother would be like, it's like you guys are talking Chinese. I don't know what you guys are talking about. But my dad was very forward-looking because when I was being raised in the 60s and 70s, my dad was cool with my liking math and science. The other thing about engineering as being foundational is it's really developing critical thinking. Whether or not you're going to use, like I took electromagnetics, well, maybe I used that a little bit when I worked in circuit boards and wires running through them, but I didn't really use electric machines because I was like those big machines and I worked in microelectronics. But what it's really developing is critical thinking skills, and that's the transfer. Also, you can do engineering as an undergrad, but not in grad, if you haven't done it in undergrad. So I worked as an engineer for 6 years, went back to school, got an MBA from NYU. You can't reverse it. My husband's a CPA. He couldn't go get a master's in engineering. So if you're sort of the least interested, it's good to start in it. And then the other thing is you can get a job. So to really build skills, whether or not they're the exact classroom skills, it really builds something that you can get a job. And then the idea of lifelong learning, which is a math teacher. Students ask me questions, or I'm also a tutor. I don't really know what you guys are doing. I've had to learn. Graphing calculator. I've had to learn that. Then I worked in finance for 5 years. And I got this question on a banker interview. So how would you do this in your head? I remember I'm from the 1900s when there weren't any calculators. So 24 times 12, oh, I gotta change that color. Anyone 24 times 12, can you do it in your head? Yes?
288.
Good, how'd you do it?
I split 12 into 2 and 10. First I multiplied 24 times 2, then added it to 24 times 10.
Okay, so you're kind of thinking, if you don't mind me saying so, you're kind of thinking of the sort of what they might call the regular algorithm. Right, so there's two 24s and then there's 10 24s. Right? Excellent, good. Another way? Anyone else? Yes?
You could split the 24 in half and do 12 times 12, which is 144, and then
Yeah.
just double it.
That's what I did. I did 12 12s is 144 and doubled it. And there's a bunch of other fun things you can do if you know perfect squares. Again, I'm dating myself here because if you know perfect squares, you can do lots of mental math. But then my career path changed. And see, now I have a son who's just your age. He's 16 going on 16 and a half, and my other son is 13. So it's like, well, now what am I going to do? I'm working at a bank. I can't really go back to work. Luckily, my husband's been at the same company forever. So when this guy was a baby, I posted up signs in my neighborhood. Math tutor available. I went to Stuyvesant High School long ago. I wrote Syracuse engineer, NYU MBA. And I got one client who were homeschoolers, and I was with them for 8 years. So not only was I tutoring them, but I was teaching them. I was developing curriculum for them. So what happened was, I really didn't foresee that I was ever going to have my own business. When I was in MBA school, I'm like, I don't cook, I don't knit, I never invented anything when I was working as an engineer. I worked with other engineers, but I wasn't thinking of inventions. But here I was, all of a sudden, with my own business. And it wasn't like I had a business plan, it just kind of came along. I'll open this in a little bit, but if you Google this, what you'll find is that very few of the actual objectives are engineering. They have things on there like lifelong learning, developing a team, working on teams and working independently, problem solving. I'll bring that up in a little bit. Now, when are we ever going to use this math? This is a talk I give to teachers and really to parents and students and anyone else. And some of you may know this radical, I call this robbing Peter to pay Paul, right? The radical's on the bottom and you're bringing up top. Right? Anyone know what I'm talking about? Okay. And then, you know why they asked you guys so much of that? Because you have a calculator. We didn't have that much stuff like that, just with sine and cosine. We didn't have that. They changed math so significantly. If you have a parent who loved, or aunt or uncle who loved math like I did, if I wasn't the math lady, I would not be able to help my 10th graders. I wouldn't be able to help them. I wouldn't know what they were talking about. So, I gotta change these colors. Anyone for 12 divided by a half? Oh, well, first of all, does anyone have a favorite division with fractions problem? Anyone? No? All right, I'll give you mine, okay? Everyone should have one, but you can borrow mine. Someone drew a very nice sine wave here. I don't know who that was, but someone drew a very nice sine wave. So 12 divided by a half. Anybody?
24, 6.
Was it?
You just multiply by the reciprocal.
Okay, which one? Which reciprocal? Yep.
Of a half.
Of a half,
it's
right?
24.
Why? Right, there's no reason to ask why. Just invert and multiply, right? Why?
A half goes into 1 and 2 times, multiply
Sure.
that by 12, you get
Okay, so
24.
you could think of it that way. You could also write it, right? This means, what does this fraction borrowing thing mean? Divide, right? Do you like having a half on the bottom of your fraction? What's your favorite denominator?
1.
1, right? Isn't 1 your favorite denominator, right? However old you are. So if you double this, you get a 1 on the bottom. So you keep change play, right? Some of you know that. So you get 24. What about 12 divided by 0?
Undefined.
Undefined. Why?
You can have it as a 0 now.
Now, I'm not going to go through all this because I haven't used a smartboard in a while, and I don't want to mess with their smartboard. But when you have 12 divided by a half, if you write it like this, you can check your work. Yes, half. Right? Anyone like to cross multiply? I love cross multiplying too. Okay. If you do 12 divided by 0, what number can you put here to get your 12 back? Nothing. Okay. So what happens is you can give these trick questions. People will think 12 divided by 0 is 0. And so what I really try to do is to have people much more self-aware. In other words, when you see that or I see that, I go, oh, they might write 0. And if it's multiple choice and they put 0 as an answer, you can bet a whole bunch of people who are going to think, oh, I know the answer because it's 0. People make fun of math all the time, and I never know if I should be laughing or crying. So this is the forever stamp. Remember when those stamps came out? Right now you just don't care how much. Anyone know how much postage is anymore? I lost track. Right, because you got that forever stamp. But look at the things they're comparing trigonometry class to. Now, one of my best friends is a tax accountant, so she loves doing taxes. Okay, but they have trigonometry class. Anyone trig favorite? Anybody? I'm an electrical engineer, so see, trig is my favorite. Simon, total favorite. Now, it is also a lot of things, especially in math, where people think if they have ability, they can do well. And if they don't have ability, they can't do well. Do you know anyone like that doesn't like math and they think they're not good at it? Okay? It might be yourself. It's okay if you want to share or not. So when this lady wrote this book, she talked about these two different mindsets. And this is really critical for engineering school because there's the growth mindset and the fixed mindset. And what she said is that people with the fixed mindset, they don't think they can get any smarter. They think their intelligence is fixed. So what do you think the average grade is in, let's say, freshman chemistry at a university? Average letter grade? C. Okay, in my classes, this was the structure of most of it. And I really like sharing this with pre-engineering students. 10% get an A. Now, what kind of students are in engineering school? What kind of students go to engineering school?
Creative.
What's it?
People who are creative.
Creative. Good. What else?
Smart.
Smart. right? They're generally pretty good academically. So you take the top 10%, they're the only ones getting an A. Right? My 1A was in Calc 2 because I took it in high school. Okay, 20% get a B, 40% was a C. I was so happy to get a C in some classes. I was so happy, I was deliriously happy in electromagnetics to get a C. Okay? And only 10% fail. But for many students who come to engineering school, they've been the best student in their class, in their math class, whatever, and so they really need to think about their grading scheme because you know what? Only your first job, and maybe not even that, will even care about GPA. So don't use that as your only feedback loop, and make sure you study with your friends. So that's how I made it through it, and that's where I was teaching math. They were teaching me science, I was teaching them math. Now, the reason I started my business, I started in 2000, but my website I created in 2003, and somebody in my community used to have an ad called Overcome Math Anxiety. And I thought, ooh, math and anxiety, they shouldn't be next to each other, so what would be better? So I thought confidence would be a better thing to put next to math. So when I started my website, I thought that would be a much better way of expressing it than putting anxiety and math together. However, really one of the key things that I really try and emphasize is that you can always rewrite your own script. So in other words, if you're a great math student, great, but you might be a better English student than you think, or you might be a better runner than you think. It extends beyond academics. This is the running part. Let me see, I'm just going to go a little bit here. What's the good wrong answer here? Can you guys see that? Oh, I really need to change these colors. So what would be the good wrong answer that people would put there? So it looks like this. I'm sorry for the colors. Well, I guess I got to put this up when I go teach at the college. So what's that N there?
The right answer or the wrong answer?
Either one. What's the good wrong answer?
The good wrong answer?
Yeah.
4?
4. 4 is the good wrong answer, right? What's the right answer? 9. Okay. So what happens is the person sees 4 and they think they're super smart. So what I really try and do, the fancy word is metacognition. How do you think about your thinking? And what I try and do is kind of step on their foot with a ski boot and go, hey, it's not 4. Pay attention. Now, how did I learn to pay attention? Right? What does a little m mean? Let's say in front of a big V. What does a little m mean?
Micro.
What's it?
Milli.
Milli. That means 10 to the what power?
Negative 3.
-3, right? What about a capital M?
Oh, I don't.
Mega.
Mega. That means 10 to the 6. So if you write, or I write, a little m and you mean a big M, you're a billion-fold off. Right? So I didn't always know attention to detail. But you have multiple choice physics and you pick the wrong thing, and pretty soon you're a billion-fold off.